Click the bell icon to get latest videos from Ekeeda.
Hello friends, in this video we are going to learn what is encoder is. Now we have seen this name, we have heard this name encoder whenever we are processing with any kind of a data. We can say in a telecommunication, when we send data, when we receive the data, the word is always used, that is encoding and decoding. Now what does encoding means? Here we are going to talk about the digital data. Digital data, that means the data which is represented in ones and zero, that is in a binary format. So when there are communication between two different computers, that means computer A wants to send some information to computer B, but I don't want that computer C, that is one another computer, can access that data or can modify the data. So the encoding of the data is required. Now in this video we are going to see how this encoding can be done and different types of encoder and how they work. So basically encoding is required when there is a communication between two different devices or two different systems to secure the data, and to securely deliver the data to that particular system, encoding is required. And to encode the data, different types of encoder are available. So first we will see what exactly the encoder is, what are the different types of encoders are available to encode the digital data, and we will see the working of each and every encoder. First of all, encoder is a combinational circuit which is designed to perform the inverse operation of a decoder. Now, these are the two different types of devices where encoder is used at the transmitter side and decoder is used at the receiver side. That means before sending a data to a communication channel. Now, to communication to happen between two different systems, you first need to have a transmitter, then the receiver, and connection between transmitter and receiver can be done by the proper channel, and this proper channel can be used as a medium to transmit that particular data. Now if I want to send the data from the transmitter, it should be encoded so that the data will be traveling in a encoded format, so it cannot be accessed by another system and the data manipulation can be avoided, so that the only receiver which is tend to receive the data, which has to receive the data, can receive the data which is transmitted from the transmitter. So at the receiver side you must have a decoder which will decode the data. So first encoding of the data is done, then that data travels from one point to another point through a proper medium, and then at the receiver side decoder will decode that information, and that information can be displayed to the receiver, whoever is the receiver. Now this encoder is nothing but it's a combinational circuit. We have seen two parts of a digital circuit, one is combinational circuit and one is sequential circuit. So in a combinational circuit, the whatever is the changes in the input, there is a change in output, so there is no feedback present. But as in a sequential, we work on a feedback, that means we work on a present input as well as the past output. But here the encoder is a combinational circuit, that means whatever is the input, if there is a change in input, then there will be change in output. An encoder produces an m-bit binary code corresponding to the n-bit digital number applied at its input. Now it's depend on the type of encoder we are using. So how many bits of input is available for that encoder and how many bits of output will be produced, that can be depend on the type of encoder we are going to use. So basically we have a different types of encoder, we will see those types, but here we have seen that if there is a n bits of input, there can be m bits of output, and n and m, this can be any number. The encoder accepts an n input digital word and convert it into an m bit another digital word. So basically digital signal can be written in a different format. For example, it can be in a binary format, it can be in a BCD format, or it can be in a hexadecimal, or like that. So you have so many types in a number system. So this data, it may be possible that at the input side your data will be in a one digital form, but at the output side your data can be in a different digital form. So it can be from the binary to BCD, or it can be from the BCD to decimal, it can be from decimal to BCD, like that. So the form is not same, it can be different for the input and output. The basic building block diagram of encoder is like that. Here you can see you have a n number of inputs. This is the encoder block which will encode the data, and the output will be produced accordingly. Here m output lines are given. So n and m can be any number. We have a different types of encoder, that is a priority encoder. That means according to the set priority, output can be produced. Second, decimal to binary. That means your input data will be decimal form, and your output data will be in a binary form. Where decimal, it has a base of 10, in binary it has a base of 2. Third type is octal to binary encoder. That means input will be in a octal form and output will be in a binary form. So that is called as a octal to binary encoder. The next type is a hexadecimal to binary encoder. Again, these are the different forms. So input will be in a hexadecimal, output will be in a binary, that is ones and zeros. Fifth one is from decimal to BCD priority encoder. So here priority is also used. That means the data will be produced according to the priority. Now what is the priority encoder, that we will see later on. But here we can say that if it is decimal to BCD priority encoder, that means input will be in a decimal form and output will be in a BCD form. Now let's see what is priority encoder is. So this is the block diagram of priority encoder, where you can see you have a 4 different inputs connected. That is, the data is connected D0, D1, D2 and D3, where the output is only 2 lines are given, that is Y0 and Y1. Now according to the priority, if the D2 is having the priority, then that data should be produced across the output line, that is Y0 and Y1. Now here the truth table for this priority encoder is given, where inputs are D0, D1, D2 and D3 and outputs are Y0 and Y1. Now here you can say if D3, D2, D1 and D2 0, this all 4 lines are 0, then there will be no output across Y0 and Y1. Now let's see the next case. The second case is where the D0 is high and other 3 inputs are at a low. That means 0, 0, 0, 1. D0 is 1, that means it says that whatever is the data at D0, that should get produced across the Y0 and Y1. Now here D0 denotes that decimal point 0, D1 denotes decimal point 1, D2 denotes decimal point 2 and D3 for 3. That means if you write in a binary, it will be 0, 0, 0, 1, 1, 0 and 1, 1. So that means according to the priority, if D0 is equal to 1, that means the priority is given to D0 out of this 4 input, then the output or the data which is at D0 input should get produced across Y0 and Y1. Now here if you see this second line, here the priority wise D0 is equal to 1, other inputs are at low, that is 0, 0, 0, that means D0 is a priority. So the data across the D0 should get produced, and that is nothing but 0, 0. It's a decimal 0 and binary 0, 0. So here your output is equal to 0, 0. Now let's see the third line, that is here irrespective of what is the value of D0, here the cross mention that irrespective of what is the value, whether it is 0 or 1, D1 is equal to 1. That means priority wise D1 is the priority. So what is the data across the D1? That is in decimal it is 1 and in binary it is 0, 1. So 0, 1 should be given as an output. So here we have output is equal to 0, 1. In third case, irrespective of what is D0 and D1, these are don't care, that means they can either 0, 0 or they can either 1. Then here priority is for D2 is given, so data across the D2 is nothing but 1, 0, so output is equal to 1, 0. Now at last you have D3 is a priority, so the data across D3 is 1, 1, so 1, 1 will get produced across the output line. So this priority can be set. Now here you can see how the priority. Now what if the D0 is also 1 and D1 is also 1? Now which one can be taken as a priority if both are having value 1? Then according to this, the higher value, that means MSB, can be taken as a priority. That means from this 4, if D3, D2, D1 and D0, in all these 4, if D0 is having value 1 and D3 is also having value 1, where D2 and D1 are 0, 0, then out of this 2, which one can be selected? Then here, if you see which one is the MSB is a D3. D0 is the LSB, that is a least significant bit, and this is the most significant bit. Then priority can be shifted to the most significant bit. That's why here we have written that irrespective of what is the value of D0, whether it is 0 or 1, if D3, that is the most significant bit, is having the priority, that is high value, then the data across the line D3 will get produced as an output. This is how the priority encoder work. Now the next type is decimal to binary encoder. Now here what is decimal to binary encoder is, that means your input will be in a decimal form and your output will be in a binary form. Now you know that decimal value can be represented in binary form. For example, if you have a decimal value is equal to 1, so you can represent it like 0, 1, or you can write 0, 0, 1, or you can write 0, 0, 0, 1. This is for if you are having only 4 numbers, that is from 0 to 4. This is from 0 to 8 and this is for 0 to 15. So this is how you can represent binary decimal into binary. So here we are having the decimal inputs, that is 1, 2, 3, 4 till 9, and these values can be represented in BCD output, or you can say binary output, where BCD stands for binary coded digit. So here A, B, C, D, these are the 4 output given. So whatever is the number you want to represent, that number can be produced across the output. Now how this decimal to BCD encoder will work? So here what you can see, that 1 to 9, these are nothing but these are set of switches. So according to the switch position, that particular data will be produced as an output. For example, you can see this is set of 10 switches and 1 for each numeral between 0 to 9. That means this switch represents for 1, this switch is given for 2, this switch is given for 3. Now if I press the switch 3, that means whatever is the data of 3, that will get produced across the output lines. Now here what is the 3? 3 is a decimal digit. So this decimal digit will be represented in a binary format in this particular output lines. Now this diagram can be understood in a better way with the help of truth table and its implementation. Now here we have the truth table for decimal to BCD number. Here you can see the inputs are in a decimal format from 0 to 9. Then outputs are given A, B, C, D. You have a 4 output lines. So here I can directly represent the decimal data into binary format. So here 0 is represented as a 0, 0, 0, 0. That is the binary format. Binary format of 1 is 0, 0, 0, 1. Binary format of 2 is 0, 0, 1, 0. For 3 it is 0, 0, 1, 1. For 4 it is 0, 1, 0, 0, like that. So first you have to write the decimal points and its binary format number in the output. Now you can see when the output is 1, that means you have to check the high output for that particular output line. For example, if the line is A, that is the first output line, here for 1 as a decimal input, that means if the switch number 1 is pressed, then it is high. If switch number 3 is pressed, then it is high. So I have circled all the high values which are given in A column. That means A will be high only when the switch pressed, that is out of 1, 3, 5, 7 or 9. So here I have written A can be high when this number of switched can be pressed, that is 1, 3, 5, 7 and 9. Similarly for B, now see when B is high, 2 and 3 it is showing 1, 1, and for 6 and 7 it is showing 1 1. That means B will be high when it is 2 plus 3 plus 6 plus 7. Similarly for C we have 4 plus 5 plus 6 plus 7, that is this. For all these 4 continuous decimal switches, the output will remain high. Now how the implementation can be done for this encoder? So basically this encoder is nothing but it is having the logic gates. So here you have the different OR gates. That means OR gate is used for the addition of 2 different numbers or 3 different numbers. It can be having a 2 input or it can be having a multiple input. So here you can see these are the OR gates having the multiple input. So the equation for A, B, C and D are given, then when it will be high. So whenever it will be high, if I am pressing the switch is equal to 1, what should happen? It should get connected to OR gate of A. So this connection is shown. You can see for A it is the addition of 1, 3, 5, 7 and 9. So line number 1, line number 3, line number 5, 7 and 9 should get connected with OR gate A. Then the A will produce output is equal to high. Then for the next B, it will be high when 2 plus 3 plus 6 plus 7. So 2, 3, 6 and 7 should get connected to OR gate of a B. Similar for a C, we have 4, 5, 6 and 7, and for D we have 8 and 9. So whenever the 8 and 9 are pressed, this 2 switch must be pressed to get the output across the D. So that is how the decimal to BCD encoder work, because so here input will be in a decimal form and your output will be in a BCD form, that is a binary coded format. Now the next type is octal to binary. When it is octal to binary, that means the base will be in a 8. So octal means your base is equal to 8. When it is decimal, the base is equal to 10. Now here we are converting octal to binary. That means input will be in a octal format and output will be in a binary format. So here the 2 extra carry inputs are given. Now the IC is known as 74148. Now we will see how the octal input can be converted into binary format. So here we have the different inputs. Since it is an octal, the input will go from 0 to 7 because n is equal to 8, and it will go from 0 to n minus 1. So it is 0 to 8 minus 1, that is nothing but 0 to 7. So we have inputs from 0 to 7, whereas output can be produced in CBA. Now we have a 3 output because 7 can be represented by 311. This is nothing but binary format of decimal 7. So here again we have to write all the decimal numbers and the binary format of those decimal numbers. So 0 represented by 000, 001, 010. Now again we have to see now at which point the A, B and C will remain high. So you can see here at this point A is high, for 3 it is high, for 5 it is high, and for 7 it is high. Then for B it is high for 2 and 3, 6 and 7, and then from 4 to 7. So I can write for A it is 1 plus 3 plus 5 plus 7. For B it is 2 plus 3 plus 6 plus 7, and for C it is 4 plus 5 plus 6 plus 7. Now the implementation will remain same. This is one OR gate which is A, this is the second OR gate and third OR gate. Now according to the level high, this OR gate will connect it to those input lines. So here you have 8 different input lines and you have 3 different OR gate which will produce an output A, B and C. So when A will be high, when 1, 3, 5 and 7 switch is pressed. So here 1, 3, 5 and 7 should get connected to A. Here we should have for B 2, 3, 6 and 7, and for C we have 4, 5, 6 and 7. That is how truth table can be utilized to implement the encoder. So these are the different types of encoder. So from this you must have understood that data can be encoded in any digital format or any number system. So basically what we do is, encoder is a block which select the data from particular lines or from particular data units, and it is converted in the required binary format or required data format. So if I want that, if I have the device which can only transmit the data in a decimal form, but if I have the device which can receive the data only in a binary form, then I have to convert decimal to binary. So for this encoding process I can use this different type of encoder we have studied in this video. So I hope you have understood what is the encoder is, which are the different types of encoders are available, and how it works. Thank you for watching this video. Stay tuned to Ekeeda. Do subscribe Ekeeda. Thank you so much.